Hello everyone, welcome to our project website. Our group project is Healthcare Facilities Accessibility and Equality in Singapore. Health facilities are an essential part of urban infrastructure. They directly affect people's quality of life. Especially in Singapore, a highly urbanized city with an aging population. In 2024, nearly 20% of the population were aged 65 and above. This increasing elderly population brings new challenges to health service planning. Therefore, this project aims to conduct a comprehensive spatial analysis of healthcare facilities in Singapore and evaluate their distribution fairness. We collected POI data of 4 types of healthcare facilities: hospitals, clinics, pharmacies, and dentists. We also used population data for each subzone, including the age structure. Firstly, we used kernel density estimation to explore the spatial distribution patterns. The results show that healthcare facilities, especially clinics and pharmacies, are more widely distributed across Singapore. High-density clusters mainly appear in the central and eastern regions. Hospitals and dentists are more concentrated in specific urban centers. Secondly, we conducted a service area analysis based on the road network to simulate a 15-minute walking catchment for healthcare facilities. Finally, we calculated the equity index, a quantitative indicator that measures the balance between population demand and healthcare facility supply within each subzone. A higher value means better service balance, while a lower value may indicate a lack of healthcare access. We developed 2 interactive web maps. One is built using Experience Builder, which allows users to search for nearby facilities based on their location. Another one is an API-based web map for visualizing the equity index across all subzones. This is the first Map Near Me facility map. Healthcare facilities are represented as colored points, classified into 4 types. Clicking on a facility point will open a pop-up window showing detailed information such as the name, address, and telephone number. At the top, we provide filter buttons to customize the display. Users can filter by facility type or region. For example, hide clinics, exclude facilities in the central area. These filters also apply to all subsequent searches. We also include road layers and service area layers. The service areas are calculated based on the actual road network. Service area analysis shows central regions have better coverage. Peripheral areas like Tuas and the northern regions have fewer reachable hospitals within 15 minutes. In addition, residential land data is overlaid on the map, helping users identify which residential areas are not covered by healthcare services and where improvements may be needed. We offer a Near Me widget for customized nearby searches. Users can input a point, draw a line, or define a polygon area. You can also customize the search radius with 500 meters as the default. The tool will then highlight the nearest facility and all facilities within the buffer zone, along with their detailed information. All results can be exported. Alternatively, users can type an address using the search box. For example, Singapore River. The map will automatically update the nearby facility results based on that address. Besides, users can also select features from map layers. For example, if you're interested in a specific residential land parcel, you can select it, and the Near Me widget will automatically update the results based on that selection. Or, you can draw a custom area of interest to search for nearby facilities. And export maps using the Print tool. Additionally, we provide statistical charts that summarize the number of each type of facility based on your selected area. We encourage user participation in maintaining and updating the data. Through the Edit widget, users can modify existing facility data or add new facilities to the map. We also provide spatial analysis tools using the Analysis widget. So, next I'm going to present our web map application developed using ArcGIS JavaScript API. So this is the initial interface. Firstly, I add some basic interactive widgets. And on the top right corner of the whole map, here is a drop-down menu for users to change the base map style. And I also add this select amenity query to filter the specific facility by different types. This is pharmacy, this is hospital and all facilities. Legend here will show you the specific symbols for each facility. And then moving to the visualization of equity analysis. Because we have Singapore's demographic data, which includes age groups from 0 to 90 plus, divided into several groups by 5-year intervals. And we calculated an equity index for each age groups. In order to dynamically show these differences, we designed an age slider from 0 to 90. As users move the slider, the map updates automatically to show the spatial equity index for the selected age group. Let me show you some visualization results. Drag this slider left and right with your mouse to observe some specific patterns. For example, take a look at the darkest purple areas, those represent subzones with the highest equity index. Drag slider from left to right. For age groups under 60 years old, most of the subzones with high index are in the central part of Singapore. But after 60, there's a shift, the high index areas start moving outward, in the outer parts of Singapore. By the time we reach the 90-plus group, the two areas with the highest equity index are Pasir Ris Park in the northeast and Pasir Panjang in the south. You can see this trend continues in those older age groups. We also add this table to show you the top 5 subzones for equity index, including the rank, name, and the index values. And this population pyramid chart is for visualizing the age-gender structure in different subzones. If you are interested in any subzone, just click on it, and the chart will be created dynamically based on demographic data in the selected region, and you can see the gender balance and age distribution. And if you feel the chart is blocking the map, you can click the fold button to hide it, and expand it whenever you want. Finally, here, expand this LISA result map. We also insert another mini-map to show local Moran's eye analysis. In our mini-map, from the legend you can see, the high clusters, shown in light red, these are subzones where healthcare resources are well concentrated. On the other hand, the low clusters, shown in light blue, indicate these regions may lack sufficient healthcare services. And just like the main map, this LISA result is also bound to the age slider. As you slide through different age groups, the LISA layer updates accordingly. So that's our visualization. Finally, this is our demonstration video and final report page. Overall, through kernel density analysis, service area modeling, and equity index evaluation, we identified current spatial patterns, potential problems, and areas for improvement in health service allocation. We think this project is really meaningful and interesting, providing a comprehensive and interactive platform to visualize healthcare facility distributions and spatial equity across Singapore. Thank you for exploring our project. Thank you so much for your listening.